Hi everyone, welcome to Cola Teaches Math. So I figured I'd make a quick video on some Unit 6 things, specifically for my class. This is the stuff that I am testing you guys on tomorrow, and hopefully you can understand the difference while I am sitting in the car waiting for my daughter at dance. Okay? All right, let's do this. So look at this first question, the blue versus the pink. Do you see how the blue has a ddx in front and the pink doesn't? So I taught you guys two fundamental theorems of calculus. These are both of them. So the blue one is asking me to derive the integral. The pink one is just asking me to evaluate the integral. The pink one requires a lot more work. Okay? So the blue one, now, if we wanted to, okay, we could sit here and integrate this orange box, plug the bounds in, right here and right here, and then get an answer and take the derivative of it. But there's a shortcut. The second fundamental theorem says, hey, make sure your lower bound right here is a constant, your upper bound is a function of x. As long as it is, it always works out. There's proofs out there that everywhere we see a t, we're going to replace it with this variable. So this dx, let me actually color code it in the same color. The derivative of this integral is equivalent to sine x squared, because I'm replacing the t with the x squared, times the derivative of the variable. So the derivative of x squared, 2x. So the derivative of the integral is this right here, okay? Now the pink one over here is saying, hey, we're going to integrate it and plug the bounds in. So this is a lot more work. So the integral of sine, because there's nothing in front of the integral, the integral of sine is negative cosine of t. Carry my bounds down. We always put the upper bound in first. So we're going to have negative cosine x squared minus negative cosine of 1. And that's going to be negative cosine x squared plus the cosine of 1. Done. It's not asking me to derive anything. It's asking me to just integrate and call it a day. Okay, next set of things you need to remember. Whenever you're anti-deriving, aka integrating, we are going backwards. I'm giving you the derivative. We're coming up with the function. So if I integrate the second derivative, we are getting back to the first derivative. Because I have a definite integral on my paper, we need to plug the bounds in. This is going to be f prime of b minus f prime of a. Next one, when I integrate the derivative, I'm going to get back to the function. That's going to be f of b minus f of a. So I need you to remember, we integrate the derivative, we're going to get back to the original. Okay, next, a few things over here in green. This is called a definite integral because there are bounds. This is a definite integral. When I say bounds, I'm referring to the a and the b. Right here. There is no plus c with definite integrals. No plus c. You can see up here for this question right here, there was no plus c. This, in this pretty green, is called an indefinite integral. There is a plus c for these. And the definite integral is the area under the curve. This equals the area under the curve. Let's see what else you need to make sure you know in Unit 6 that I think is important. I think that's good. There we go.